So how do we calculate the heat of a reaction, the delta H of a reaction? Well, we could estimate this using average bond enthalpies, but it would only be an estimate, even though it would be a relatively good one. But that actually only works for gas phase reactions. So is there any way that we can calculate the delta H of a reaction, any reaction, to have it be accurate? Well, there is. Let's start by imagining that we have some reactants and we want to go to products. And we know that that is what we want to find the delta H of, right? We want to find this delta H, the delta H of reaction. And we sometimes have a little circle here saying that we're talking about standard conditions. Okay, so that means we have pure products being formed from pure reactants. Okay, so one thing we can imagine doing is, what if we broke our reactants down into elements? And we called that step 1. And then we took those elements and used them to make products, and we called that step 2. This path of going step 1 and step 2 gets us the same place as if we went there directly. And since delta H is a state function, we can say that this upper path, which we could call path B, is going to be the same delta H as the lower path, path A. It must be that they're equal. So we can say delta H for path A is going to be equal to delta H for path B, because it's a state function, right? It only depends upon the initial and final state. It doesn't matter what the path is. So that means we could, if we could somehow calculate this step 1 and this step 2, we could get the delta H for the reaction. And this is really convenient because we would only have to, as chemists, tabulate this energy and this enthalpy and this enthalpy, and then we can combine those for any reaction to get the delta H, and that's exactly what happens. Let's do step 2 first. Let's call step 2 what are we going to call that? Let's give it a name. Let's call it the heat of formation, because we're forming compounds from the elements. So it's the heat of formation of products. And of course, if we were going from the elements down to the reactants in this sort of leftward direction, we'd call that the heat of formation of reactants, but that's not what we're doing. That's not what step 1 is. So let's call step 1 something else. Let's call that the heat of formation of reactants, but because we're going in the wrong direction, let's call this the negative of the heat of formation of reactants. Okay, and let's give these some names. Let's scroll down here a little bit. We're going to call this the negative of the heat of formation of reactants. So here, the symbol for the heat of formation of products would be the same, except for we have products. So once again, these heats of formation are just going back and forth between the products and elements or reactants and elements. So we can say that delta H of reaction is equal to delta H of formation of products minus delta H of formation of reactants. And that minus sign just came about because we were looking at that reaction backwards, so it just naturally appears. So we have this equation And this will allow us to calculate the delta H of any reaction. We'll do an example in the next screencast.